Hi guys, welcome to a video. Today in biology we're going to be looking at states of matter, which is actually chemistry, but they actually link quite well, okay? Just before we begin, I just want to let you know that this is published on a YouTube channel. My school account, I'm going to be publishing videos a couple of times a week. So if you subscribe to the YouTube channel, you can see the videos when they appear. And that means maybe you're busy, maybe, I don't know, maybe you're in your bedroom, you're just on your phone, you don't have access to your Chromebook. If you subscribe to the channel, the video appears and then you can just watch it whenever you're ready. Okay? Another thing, so sometimes we'll be having classes via Google Meet, like in a video chat, and sometimes I'm going to give you videos like this with some work to do after. So today you just need to watch the video and then answer the questions afterwards. Okay, so let's start the class. Okay, so we're talking about states of matter today. So first question, what is matter? So matter is everything around you, okay? It's the Chromebook you're looking at, the air you breathe, the juice you drink in the morning. Everything around us is matter. Even if we cannot see it, it is made of matter, like gases, okay? And things that we hear, that we can touch, they are also made of matter, okay? So what are the states of matter? Well, solids, liquids, and gases, okay? Now there are others. There's plasma, and then there's Bose-Einstein condensates, okay? However, these are not found naturally on Earth, okay? Plasma is normally found in a very, very hot environment, like in a star, like the sun. So not found naturally on Earth. And a Bose-Einstein condensate is a man-made matter. That means we invented it. It doesn't occur naturally. These two are by having a very, very high or a very, very low temperature, okay? So it's not found naturally on Earth. The three which are found naturally on Earth are solids, liquids, and gases. So let's look at these three. So a solid, liquid, and gas, the particles are the same, okay? The particles are identical in solids, liquids, and gases. The only problem is the behavior of the particles is different, okay? So if you look at a solid, look at all these particles, which are the tiny parts which make up something. So these tiny particles, they're small and they're held together very tightly, okay? There is no space, so not much space between the particles. Now in a liquid, the particles can move around and there's a little bit of space between the particles. And in a gas, the particles move around quite a lot and there's a lot of space between the particles, okay? So that is the only difference between solid and liquid and gas, is the behavior of the particles. So these are just some examples, okay? So solid, obviously we have ice, and then if you heat it, you have water, and then if you heat that again, you have vapor, okay? Just some other examples. So iron is solid, salt is solid, mercury is liquid at room temperature, oil is liquid, and oxygen is a gas, and carbon dioxide is a gas. These two are very important in respiration, which we're going to look at in another class. So solids, liquids, and gases differ because the particles behave differently, okay? So here we've got a picture of Iceman. And I just want to have a look here. So let's imagine we're only talking about water, okay? Only talking about water. So water, in the ice form, the particles are held together very, very tightly, okay? And notice the temperature is very cold. If we increase the temperature, the ice will melt. So the particles of water, they have more space and they can move about a bit more freely. If we heat this liquid even more, now it's very hot temperature, we now have water in a gas form, water vapor or steam. The particles are a lot of space between them and they're moving around very, very freely. But something which is very important is that the particles are the same. They're just doing different things, but it's still the same particle. Because water is H2O, okay? So you have two hydrogen atoms and one oxygen atom. And if that's in ice, liquid water, or vapor, it's still H2O. But it's just doing different things, moving in a different way. So, how can this relate to biology? Because what we've been doing so far is chemistry. Well, the water cycle is a really good example of states of matter which change. Okay, let's start by let's talk about this river. Okay, so water goes down this river, and it goes into this, and it goes into the sea. Okay, so water here is in a liquid state. Okay, now when it gets out of the sea into the ocean. The temperature causes the water to evaporate. So that means it turns from a liquid into a gas. Okay, so from liquid, it evaporates and rises into a gas. Okay, so water is now in the vapor stage. Now, as it gets higher and higher, the temperature starts to get quite cold. Okay, so that water vapor starts to condense in this process, condensation. Now, condensation can be from a gas into a liquid, okay? And then, as we know, when it becomes a liquid, it can come down as precipitation. If the temperature is very cold in this step, obviously it can fall down as a solid, maybe something like snow or maybe something like hailstones, okay? But generally it comes down as a liquid, okay? And this is precipitation where it's coming down the rain, okay? And then this rain, which is water, it can be solid as snow or hailstones, but generally water, it will land on the ground and then it's going to try and find a source of water, okay? So it's going to flow onto these leaves, onto the grass, and maybe down into the river. And this will connect and collect into a big river, and then the cycle repeats, okay? So we start with collection, then evaporation, then condensation, and then precipitation. And each one of these can have changes in the state of matter, and in this case, the state of water. So this is what I'd like you to do today, okay? You've got 6 questions. Now, what I would like you to do is open a Google Docs and answer these questions in the Google Docs, okay? Then I want you to upload it to Google Classroom and then submit it, okay? So you've got 6 questions. 1, what are the 3 states of matter found commonly on Earth? Give an example of each. Why are they different? A change in what causes a change in the state of matter? What is the water cycle? And what are the 4 stages of the water cycle? Okay, that is the end of our video today. I'm online for the whole class, so let me know if you have any questions, and I look forward to marking your work. See you next time. Bye.